Hello everyone, welcome back. In this video, we will walk through a complete PCB design workflow using Altium Designer. To keep the demonstration simple and practical, we will use a classic MC34063 based DC-DC converter circuit that generates plus 12 volts and minus 12 volts from a 12-volt input supply. The goal of this video is not to deeply analyze the converter design, but to focus on the essential PCB design steps inside Altium. We will begin with schematic capture, then move to PCB layout, discuss component placement strategy, perform basic routing, generate Gerber files, and finally review the online fabrication process. This type of workflow is extremely useful for students, hobbyists, and practicing engineers who want a clear understanding of how a real board moves from design to manufacturing. Before we proceed with the design, it is important to mention software access for students. Altium Designer is available to students through Altium's official student license program. Students who are enrolled in a recognized educational institution can apply for a free educational license, which provides access to the full Altium Designer software. This license is primarily intended for learning, academic projects, and non-commercial use. If you are a student and wish to practice professional PCB design tools, this program offers an excellent opportunity to work with industry-grade software at no cost. Details about the application process can be found on Altium's official website. Now, let us continue with the project. Let us briefly review the circuit before moving into the PCB design. The design is based on the MC34063 switching regulator integrated circuit, configured as an inverting DC-DC converter. A 12-volt DC input supply is applied at the left side of the schematic. The MC34063, together with the external inductor, diode, timing capacitor, and feedback network, generates the required negative output voltage. The energy storage element in this converter is the inductor, while the diode provides the current path during the switching cycle. Capacitors are used for input filtering, output smoothing, and stability of the control loop. The feedback resistors set the output voltage level by controlling the internal comparator of the MC34063. From the generated negative rail, additional filtering components are used to obtain a clean and stable minus 12-volt output. The positive 12-volt rail is directly derived from the input supply, followed by an LC filter network to reduce noise and ripple. Together, the circuit provides dual output rails, plus 12 volts and minus 12 volts, suitable for analog circuits and signal conditioning applications. With this basic understanding of the circuit, we can now proceed to the Altium design workflow. Let us begin by creating a new project in Altium Designer. From the File menu, select New, and then choose Project. In the Create Project window, select the PCB project type. Enter a suitable project name and choose the desired folder location. After confirming the settings, click Create. The newly created project now appears in the Projects panel. At this stage, no design documents have been added. Next, we will add a schematic sheet to the project. Right-click on the project name, select Add New to Project, and then choose Schematic. A blank schematic document is created and opened in the workspace. It is good practice to immediately save the schematic file with a meaningful name. Right-click on the schematic document, choose Save As, and enter the required file name. Once saved, the schematic document is properly linked to the project. We will now add the PCB layout document. Again, right-click on the project name, select Add New to Project, and choose PCB. A blank PCB document is created. Next, we will create libraries to store our components. Right-click on the project name in the Projects panel. Select Add New to Project, and then choose Schematic Library. A new schematic library document is created. This library will contain the component symbols used in the schematic. It is good practice to save the library file with a meaningful name. Now, we will add the PCB footprint library. Again, right-click on the project name. Select Add New to Project, and choose PCB Library. A new PCB library document is created. this library will store the physical footprints associated with the components. With both the schematic and PCB documents added, the project structure is now ready for design. In the next step, we will proceed with schematic capture. Before continuing with the schematic, let us adjust the page settings. Go to the View menu, select Panels, and then choose Properties. The Properties panel will now appear on the side of the workspace. From here, the schematic page parameters, including sheet size, can be adjusted. With the workspace properly configured, we can now proceed with selecting the required components for the design. For selecting components, online distributor websites such as DigiKey can be used. For example, if we search for the MC34063, we can view multiple options of the same device from different manufacturers. These portals provide important information including datasheets, package types, availability, and pricing. While selecting a component, it is essential to verify the package style, voltage ratings, and other electrical specifications relevant to the design. Once the correct part is identified, the datasheet can be downloaded for reference during schematic and PCB development. One extremely useful feature of distributor websites such as DigiKey is the availability of EDA and CAD models. On the product page, we can find a dedicated section labeled EDA CAD models. These models typically include schematic symbols, PCB footprints, and sometimes three-dimensional representations of the component. Using vendor-provided models can significantly reduce design time and help avoid common symbol and footprint errors. After downloading the models, multiple Altium-compatible files may be available. The SCHlib file represents the schematic symbol library, containing the graphical symbol used in the schematic editor. The PCBlib file represents the PCB footprint library, defining the physical land pattern used on the printed circuit board. The intlib.pkg file is the integrated library package, which conveniently combines both the schematic symbol and PCB footprint into a single reusable component. In some cases, a step file is also provided. This file contains the three-dimensional model of the component, enabling accurate mechanical visualization within the PCB environment. Depending on the preferred workflow, we can either import the individual library files or directly use the integrated library package. This approach improves design reliability and speeds up the overall development process. After opening the downloaded schematic library, the component symbol is visible. To reuse this symbol in our project, we will copy it into our own schematic library. Right-click on the component entry and select Copy. Next, switch to the schematic library created within the project. Right-click inside the library workspace and select Paste. The component symbol is now successfully copied into the project library. This method allows us to reuse verified vendor symbols while keeping all design assets organized within the project. To maintain a consistent naming convention for integrated circuits, we will adjust the designator. In the Properties panel, locate the designator field. Change the value to $? This ensures the component follows the standard IC reference format during schematic annotation. Using proper designators improves readability and keeps the documentation organized. To improve schematic readability, the pin positions of the symbol can be rearranged. Clear and logical pin placement makes the circuit easier to understand and reduces wiring complexity. While editing the schematic library, individual pins can be rotated as required. The space bar can be used to rotate the selected pin during placement or movement. This allows the symbol to be organized in a way that best matches the functional flow of the circuit. Proper symbol layout greatly enhances schematic clarity, especially in complex designs. In a similar manner, the PCB footprint can also be transferred into the project library. First, open the downloaded PCB library containing the component footprint. Select the required footprint from the library panel. Right-click on the footprint entry and choose Copy. Next, switch to the PCB library created within the project. Right-click inside the PCB library workspace and select Paste. The footprint is now successfully added to the project library. This approach ensures that verified vendor footprints are reused while maintaining proper project organization. For selecting passive components, we will again use the Digiki website. In this design, most resistors are planned in the 0805 surface mount package. As an example, let us search for a 1 kΩ resistor. In the search bar, type 1K resistor and review the results. From the category list, select chip resistor surface mount. This filters the results to standard surface mount resistors. Next, apply the required package filter and choose the 0805 size. While selecting the component, verify important parameters such as resistance value, tolerance, power rating, and temperature coefficient. After confirming the specifications, the datasheet and CAD models can be accessed if needed. The same approach can be followed for selecting symbols and footprints for other components in the design. For many commonly used parts, Altium Designer already provides default schematic symbols and PCB footprints. These built-in libraries are sufficient for standard components such as resistors, capacitors, inductors, and diodes. Using default libraries simplifies the design process and significantly reduces development time. While placing components, it is important to verify that the selected footprint matches the actual package specified in the datasheet. If a suitable model is available in the default libraries, it can be directly used without creating a new component. This allows faster schematic capture and PCB layout while maintaining design accuracy. With the required components and libraries prepared, we can now begin drawing the schematic. Open the schematic document from the project panel. First, we will place a 2-pin connector to provide the 12-volt input to the board. For faster component placement, a keyboard shortcut can be used. Click anywhere inside the schematic workspace. Then type P, followed by P, to open the Place Part command. This method is significantly quicker than navigating through menus and is widely used during schematic capture. In the Place Part window, we can choose components from the available libraries. For adding the input connector, select the Miscellaneous Connectors library. This library contains commonly used connector symbols and footprints. From the component list, choose a suitable 2-pin header or connector. Once confirmed, place the component onto the schematic. While placing a component, its orientation can be easily adjusted. Press the space bar to rotate the part. Each key press rotates the component by 90 degrees. To mirror the component, press the X key for horizontal mirroring. Press the Y key for vertical mirroring. These shortcuts allow quick and precise positioning during schematic capture. The actual connector to be used can be selected from the Digiki website. In this example, a 2-position screw terminal block is chosen. Screw terminals are commonly used for power input connections due to their mechanical reliability and ease of wiring. While selecting the connector, it is important to verify parameters such as pin spacing, current rating, and mounting style. An additional advantage is the availability of EDA and CAD models directly on the product page. Download the CAD model from the component page. Open the downloaded PCB library containing the footprint. Copy the required footprint into the project's PCB library. This ensures the component package is available within the design workspace. To visually inspect the footprint, press 3 on keyboard to enable the 3-dimensional view. This view helps verify the physical representation and orientation of the component. To ensure accurate bill of materials generation, we will update the component comment. In the Properties panel, locate the comment field. Enter the manufacturer product number taken directly from the product page. Using the exact manufacturer part number improves component traceability and reduces ordering mistakes. This practice helps maintain consistency between the schematic, BOM, and procurement process. Next, we will assign the PCB footprint to the component. In the Properties panel, open the Footprints section. Click Browse to view the available footprints in the project libraries. From the list, select the footprint that matches the physical package of the component. Confirm the selection by clicking OK. The component is now correctly linked to its PCB footprint, ensuring proper representation during layout. Following the same procedure, the remaining components are placed and the schematic is completed. For creating electrical connections, the place wire command can be used. A faster method is the keyboard shortcut P, followed by W. Proper wiring is essential for defining correct circuit connectivity. To simplify the schematic and avoid long crossing wires, off-sheet connectors can be inserted. Off-sheet connectors can be placed using the shortcut P, followed by C. These connectors help organize complex designs by clearly indicating signal flow between different sections of the schematic. Using off-sheet connectors greatly improves readability and reduces visual clutter. At this stage, the schematic annotation is still pending. Annotation will automatically assign reference designators to all components. At this stage, we will perform schematic annotation. Go to the Tools menu, select Annotation, and then choose Annotate Schematics. The schematic annotation configuration window will appear. Annotation automatically assigns unique reference designators to all components in the schematic. Review the proposed change list displayed on the right side. Once verified, click Update Changes List to apply the annotation. This ensures that all components are properly numbered and uniquely identified. Proper annotation is essential for PCB layout, bill of materials generation, and documentation. The schematic has now been successfully annotated. Each component is assigned a unique reference designator, ensuring clear identification throughout the design. This automatic numbering eliminates conflicts and prepares the project for PCB layout and documentation. With this, the schematic design for our project is complete. We have created the project, selected components, prepared libraries, placed symbols, connected the circuit, and performed schematic annotation. These steps form the essential foundation of any successful PCB design. In the next video, we will move to the PCB layout stage, where we will import the schematic, perform component placement, define the board outline, and begin routing. Thank you for watching, and I will see you in the next video.